right? All right, yes, should be live. So another draftphysics.com, debatephysics.com, also video presentation. All right, and so I am doing a response in sorts. I didn't watch a Dispar video, but I did see it, so I hadn't checked his channel in quite a while. Now he's still doing experiments, all right, where he's using rubber bands that are stretched in this form. So the rubber bands are put across. Camera's a little bit crookedy. Can I fix that? Yeah, I fixed it. Okay, and he's comparing how much he swings something in and moves the rubber band some more distance. And so, as I have pointed out, as I did the math, which I'm not a big fan of, realistically. The fact is you can figure out that you can't do this measuring this way. You can't measure how much you push in because it isn't proportional to how much you're actually stretching the rubber bands. So let's see if he has the integrity to accept the truth that, Pythagorean theory says so. That it doesn't take that much work to figure this out, okay, that this length is not proportional to that length, and that this hypotenuse grows disproportional to that length. And so I'll do the numbers again, but let's see this. So if I did it in clear 1 unit of distance, okay, and then 2 units of distance, and then 3 units of distance, and then 4 units of distance this way, the numbers came out. So this was, let's just say this is 5 centimeters. Doesn't really matter what number we use. Okay, so you start off at 5.0. The 1 unit of distance, all right, you end up with 5.099. All right, so this is your 1 unit of distance. This is what 1 unit of distance, 1 mark equals 0.99 stretch in the rubber band. That's how much it does. And then 2 units of distance, you get this huge jump, okay, to 5.385. Obviously, almost, 4 times the 99. So it's a lot more than what it should be, which is twice. So this is 2 units, this is 1 unit, this is 0 units of distance. All right, so I put a line here. All right, and then 3, okay, your number gets, really big, okay, so now we're going 8, okay, 3, 0. So obviously 8 units of distance, and you only did 3, so huge disproportion, gigantic. And then you end up with, for the fourth, 6.403. So now you're a whole, 14 more. So it's only 4 times the stretch, 4 times the distance, but you're at 14 times the stretch in the actual rubber band. You've stretched the rubber band 14 times the distance. All right, so I did this in a previous video like 3-4 days ago, and he hasn't updated his video to fix any of this. So this is, again, I'll just prove that, as I pointed out with his milk carton experiment, he didn't figure out the simple variables that are involved. And again, in another experiment, he's assuming, okay, that he can do the experiment this way because he doesn't understand the variables. And so he's just deceiving people. And so will he correct the deception? Will he do anything to augment the video to demonstrate that he did the calculations incorrectly, that the distance that he's measuring is not proportional, okay, to the stretch of the rubber band? You can't use this you can't use this distance, okay, to understand how much you've stretched the actual rubber band. The two numbers don't line up. They're not the same. They're not proportional. And therefore, his whole experiment is garbage. So as far as I can tell from the experiment, I didn't play the video, is he just keeps adding and saying things like, well, it should. Gary says it's 4 times the energy, but it only moved 1.7 times. And obviously, by these numbers, you could understand why he's way under calculating the actual stretch in the rubber band. So, so let's just see if he'll man up, be honest, correct the video, annotate the video, put a new title on it or something, or frankly, he should just take it down as complete rubbish because his assumptions are completely inaccurate. So will he have the integrity to do any of that? I claim not. So I probably should change the title of this video, as I'm working. Just because it's going to have something of, I figured on playing a video by, whatever this channel name is, Jason guy, and just because I'm curious, so I figure if I'm going to watch the video, you might as well watch the video. It's a reasonable enough thing to do. So where the hell is it? Must be here somewhere. So math and science. So he has a couple of videos. Unfortunately, he's decided to do this member-only thing. So, there's videos listed that I'd be curious to see, but I have to wait till they become dememberized. I mean, it is kind of pathetic that these, actually these channels have to keep doing this whoring for money bullshit. Just kind of tragic and sad. Living in poverty sucks, but I mean, science really shouldn't be commercialized. It's just kind of, it's tacky. Yeah, that's the word for it. You can't really imagine in the old days scientists exchanging letters and then, putting a tax, or something inside the letter. You have to pay me, send me $5 or I won't respond to your letter. Some kind of bullshit. But whatever. Well, everything's always been a racket. I mean, they did have to pay quite a lot to publish, and, that's tragic too. And then, even Isaac Newton, as much as he's an admirable character, I mean, the whole reason why he didn't publish his calculus is because he wanted to control the authority of it. Like, somehow it has to have his seal of approval or nobody can mention it. And it was just tacky. Frankly, I couldn't understand what, it doesn't connect to any financial gain, and you're just saying, so it's just about his ego thing or something? I don't know. Very strange. So anyway, yeah, so I guess we'll play that video. So anyway, the title is, Where Do Atoms Come From? And do atoms last forever? And so I'll make my obvious argument that where they come from is gravity. As interesting as that sort of sounds, is that obviously the suns are under high pressure, and the fact that physics acknowledges the high pressure and they don't acknowledge the consequence of high pressure, which is heat. So it's just kind of funny that they'll concede that gravity is creating the high pressure, but they won't concede that gravity is creating enormous amounts of heat. Now, where the hell is my red pin? Well, this one I'll have to do, I guess. This is, very, very hot. So the Earth is doing the same thing in the sense that it's, 5,000 degrees centigrade there in the middle, and then there's this whole liquid part, that's a little bit cooler, but still very hot, and you have to go further and further out before it starts to cool down. But yes, the heat is generated in the very high pressure, and all the movement of material, and all that movement gets consolidated into that center. It has to go through that center in a way. I mean, there is movement going this way, sideways, and movement going this way, sideways, but that's all movement that has to translate. It all ends up getting translated into the direction that the primary force is going, which is in. So, but anyway, so there is a furnace there to create things, but how can it create them without, where does it get the pieces? So there's no idea that you can collect a bunch of electrons and protons from space, because there aren't a bunch of electrons and protons in the space. So, building atoms, what do you build them out of? Well, the trick is you build them out of atoms. You break atoms. This furnace is breaking as much stuff as it is making stuff. It's just constantly transforming the nucleuses, making them, breaking them, making them, breaking them. And that's the real engine. Now, yeah, I don't know if I want to get into the whole argument about the fission-fusion thing and the fact that physics thinks they can fuse something, push it into each other and consolidate it and make energy that way. And I guess I would argue that obviously pushing things together requires energy. Okay, breaking them apart releases energy. And so there is no fissionable, profitable fission available, that you really just can't do it. So we'll see what he says about how atoms are made and whatnot. Yeah, so I do have to probably fix volumes and such. Volume's been very irregular today, so I can't be sure of my own settings, so we'll have to just see what happens and such. Alright, let's load the video and see how it goes. Come on, YouTube. I clicked on it.
My energy bill dropped from $150 to $50 by doing this. My friends laughed at me when I spent $49 on a power saver device.
Of course, you already know that anything that...
Okay, so I have to see how loud that is. So I have to move this over and then we'll pop it out, I guess. And let's see, I have to fix it so that works. Turn that on and let's see. Nope. Let's see, I gotta find what's it called? Where do atoms come from? Oh, it did the whole window. I don't want the whole window. I just want the pop out. Fuckers. That's what I want. Okay. Close enough. And the volume on the video's up. That's up. All right, we'll see what the volume's like. See what it does. Let's just see.
You look at in everyday life is made of trillions and trillions and trillions of atoms. Of course, some of these atoms that are heavy, like uranium and plutonium, are unstable and what we call radioactive. So if you leave them alone, they will spontaneously transmute into a totally different element on the periodic table as the nucleus decays. But what about a cup or a pencil or a block?
They'll split. So yeah, the big heavy ones are unstable. They obviously can be put in a condition where they'll decay, and obviously you can change how fast they decay by crowding them. So just obvious, that's how they made the nuclear bomb, is to put a bunch of uranium, and the uranium was very dangerous just as it existed without exploding it. It was still really, I think actually in the Manhattan Project there was a couple people killed by an accident they had just playing with the little kernel of uranium that was going to be in the bomb. Because any exposure was just, it was very radioactive, very hot without even being a bomb yet. But anyway, so yeah, you can crowd this stuff and it'll decay even faster. So obviously decay isn't something inside the atom. There's not a 10,000 year timer that ticks inside the atom. It's an environmental circumstance. So something in the environment causes the decay. And so there's an event that takes place, some sort of event that isn't very likely for some atoms. And so it's 1 in 10,000 years that event takes place on average, that kind of thing. But it's obviously an external environmental condition that causes the decay.
Block of concrete, or for that matter, any other common object. If you leave matter alone on the counter and totally undisturbed, will the atoms inside ever decay, or will they ever change at all? In other words, do atoms...
So he's saying at a constant temperature and in a peaceful environment, will they decay? And yes, the argument would be no. I believe that would be the argument.
Last forever.
Unnecessary.
Now, I think that one of the coolest things is that you can take a lump of pure carbon, which by the way is dark and pretty honestly ugly, and rearrange how the atoms inside are actually bonded together into a new structure that we call a crystal structure. And with those very same carbon atoms, you can get what we call a diamond.
So again, who is he talking to, in these videos? I mean, a lot of these subjects are kind of obtuse, complex maybe. And he talks as if the audience is imbeciles, fourth graders or something. And I just don't get it. I mean, I don't get it. Yeah. But I sort of get the idea that you can't, the physics is so full of crap that it isn't really built on any kind of anything you could actually know. I mean, I could say the law of the lever. I thought it was well-established physics, but apparently all of physics doesn't believe in the law of the lever. I mean, if we push and shove them, they'll say, no, levers don't conserve momentum, because they have to say it conserves kinetic energy. It just doesn't make any sense, because, frankly, everybody should know levers do work. They do conserve energy in the sense that they conserve momentum. So anyway. Let me just check the chat for the fun of it. Let me put it somewhere where I can see it, maybe even. Alright, so I can almost see it. Alright, hello. Saw a video about how when meteors enter Earth's atmosphere, they actually slow down. Well, obviously they slow down hitting the atmosphere. It's a tremendous, they're hitting a brick wall in a sense. They're moving so fast that you can just understand they're hitting a much higher density of atoms per unit of time, then it would be the same thing as you banging into some really, like swimming in water, or even it's a real impact because of how fast they're moving. It's a tremendous amount of back pressure they get from the atmosphere. So but I think the real key argument is meteors are a perfect proof that gravity is a time-dependent force, because they gain almost nothing from Earth's gravity in terms of their momentum. Their velocity is only increased by the tiniest amount before they get to the atmosphere. So before they start slowing down, they barely speed up. I mean, we're talking about a 0.00001% increase in their velocity. So, because they're moving through the gravity so fast. Alright, gravity doesn't speed them up, but I guess without an atmosphere, they would speed up. No, they wouldn't. See, that's the whole point. They're going to go through hundreds of miles of gravity. Hundreds of miles of gravity in a second, a half a second. So you can understand, if I go hundreds or 1,000 miles away from the Earth, or 10,000 miles away from the Earth, the gravity is getting exponentially, well, quadratically weaker and weaker. And they're going to go through that entire distance in 2 seconds. And so all they're going to get is 18 meters per second increase in their velocity, 19 meters per second increase in their velocity. That's all they're going to get, is 2 seconds worth. 18 meters per second. They're going 40,000 meters per second or 50,000 meters per second, and they're going to gain 18. That's the truth. That's the real physics that these fakers won't say. These fakers. These fake scientists who couldn't care less about these absolute facts of our existence.
Now, as you know, a diamond is sparkly and beautiful and one of the
why are you wasting everybody's time, right? So who doesn't know this? A 12-year-old, 14-year-old knows that diamonds are hard substances. Yes, we all know you make diamonds out of carbon. So he's, most of his video is this putrid, explaining how to ride a bicycle stuff.
Hardest natural substances around. And the old saying is that diamonds last forever. But is this really true? Well, actually, when you dig a little deeper, the arrangement of these carbon atoms inside the crystal that we call diamond is indeed slowly but surely transforming into something else entirely, because the actual arrangement of these carbon atoms do change over time, the connections or the bonds between the atoms.
Okay, fine. I mean, you could understand that there is probably some interaction with the atmosphere that's polluting the surface, so they're oxidizing like anything else would. Now, if he's going to argue that maybe they're degrading from the inside out, that would be a more challenging argument to defend, but they clearly aren't pure. So that's the real argument, is none of these substances are free of impurities, and impurities will rot things. It will cause them to rot. It's like a little bit of water, inside of an iron pipe, and eventually, it'll oxidize a hole in it if you give it enough time. All right, slightly off topic. Oh, Valerie is crazy. Yes, he's actually commenting on my video, which you're just saying doesn't make any sense at all. And it's like he's not even close to the subject. I mean, you can't even get him to acknowledge the subject. Anyway, slightly off topic. Even if I would disagree with some topic, I am against doxing. Just saw your latest video. Doxing is not cool. Yeah, well, I'm just saying, I've been there and done this, and again, it's really not about me, okay? I can take having the cops show up at my house. I can take talking to the poor guy delivering $40 worth of food, and I have to tell him I didn't order it. I've had to do that like 6 times. I can handle that. But like I said, I live in somebody else's house, okay, a girl's house. And she doesn't like it. I mean, she doesn't like feeling threatened. And that's all he's doing, is threatening her. So that's the part where you're just saying, gee, I mean, how cruddy a human being can you be? You're going to pick on, some peripheral character that's connected to me and harass them? I mean, that's pretty disgusting. Anyway. Continuing.
But that raises a really cool question that dives into the heart of quantum.
So what is all this crap? Okay, dives into the heart of quantum crap. So what is this shit? I mean, they keep showing all this wooey crap. I mean, they have this whole disc, like black holes are now Saturn, and they have a disc around them. And I mean, it's all gotten so goddamn silly. What the fuck is this crap?
Theory and matter. If diamonds don't really last forever because the arrangement of the atoms slowly change inside of the crystal, what about the atoms themselves?
So he didn't explain any of that so far, right? We don't have any idea what he's talking about this crystal refracturization or whatever the fuck it is.
Individual carbon atoms, or any other atom for that matter. Do the building blocks of our universe have an expiration date? In other words, do they stay the same over time, or do the individual atoms that are listed on the periodic table slowly transform into something else?
Well, they're really elemental. So my argument is they're not doing any of that swirly shit. So obviously that eliminates any real problem. And they're just geometry. So they're like having 4 black checkers and 8 red checkers, and you have them in an arrangement where they're balancing each other's forces, and there's nothing to pollute that. There aren't any muons, and there's no neutrinos, and there's no gluon frogs, there's no bugs, there's no ants. So it's a pretty rigid geometry. So, theoretically, the only way you can break it is maybe throw it into the center of a sun or something, and it's going to get annihilated just because of the intense amount of action, vibrations that are going to just rip it to pieces and then rebuild it with the same pressure it's tearing it apart. It's going to rebuild it again. So I mean, that's what the furnace is doing. Yeah. Okay. Yeah. I don't. So the argument would be is if you just have a single atom sitting in space that's of a stable geometry, it ain't going to do anything. There's nothing, I mean, unless some kind of super gamma ray hits it or something, you could imagine it might break the nucleus. But it has to hit it just right.
Now, atoms all by themselves are actually quite incredible. So a good analogy would be here that the atom is kind of like nature's Lego brick. Everything you see around you, from the air that you're breathing in.
Right. So, you know, a much better way of describing this is that everything that exists is made out of this elemental universe of just electrons and protons in arrangement. And that's the only real universe. Whatever that universe does, whatever the action is in that universe, creates all of this. And we are moving insanely slowly compared to all those little bits. I mean, we can't even imagine the density of our distance from it, in the sense of the apple is to the earth as the electron is to the atom, and as the yeah, there's another comparison, and I'm forgetting it. Well, anyway, the atom is to an apple what the apple is to the size of the earth. So you just say one apple and the size of the earth, and you can just get some idea of how distant we are from the actual universe that's producing us. And it's just like, you know, we have to deal with stuff happening in units of time like a second, you know, and it's dealing with units of time that are, you know, a trillion times more notches.
Right now to the device that you're watching this video on, pretty much anything that you touch is made up of these incredibly tiny particles. But here's some.
So again, the tiny particles are the electrons and the protons. The atoms aren't a thing. They're a composite. They're made out of just a geometry between the charges, the electrons and the protons. They're the structure. They're the building block. They're the Lego.
Something that I think actually is kind of mind-bending. Some atoms have actually been around since the very beginning of the entire universe, while others, well, they...
So I'm just saying, I don't know if he has any real proof of that, okay, that they haven't been to multiple places in the universe and been part of suns and all that kind of crap. I don't think anything could have left a sun, you know, 13 billion years ago and interacted with nothing in 13 billion years. Doesn't seem probable.
They live shorter than the time it takes for you to blink. Here's a side note. There's a famous scientist that I've read a lot about. His name is Richard Feynman. He was probably...
Oh, so, you know, this is just so, again, who is he talking to? This is a video for 10-year-olds? I mean, he has to introduce us to Richard Feynman.
the world's foremost expert in quantum mechanics.
Oh, brother, so that's a real stretch. I mean, Leonard Susskind and lots of other people probably can take some credit for being experts too, but who cares? I mean, Feynman was such a shit talker in the sense that, again, he conceptually couldn't draw the two-slit experiment in any way that resembled the truth. And he couldn't talk about what experiments were done in any way that resembled the actual experiments. And, you know, so it's just an amazing fuckhead in a sense. But whatever.
At his time, and a Nobel Prize winner, and so on and so forth. But Feynman often did a thought experiment. What would be a single sentence that if you had to rebuild civilization, specifically if you had to
Oh, I mean, geez. So what is this? Single sentence to rebuild civilization? Make a gun. Yeah, buy guns. Shoot it.
rebuild all of scientific knowledge, like if everything was wiped out and you could only pass one sentence to the people that were rebuilding civilization, what would be the one single sentence that could pack the most information and kind of help them rebuild everything?
I don't even, this is just like some sort of spiritual, what is this? How is this physics? How is this science? This mush about, oh, how do you quantify the entire function of the physical mechanical universe in one sentence? You don't.
Everything that we know about science. You know, some people might try to describe how to build a computer in one sentence. That's not going to be so helpful. Some people might talk about chemistry, or some people might...
He's just dragging this out like this great... You think it's going to be a wonderful sentence? It's really going to knock us all over with, oh, that's so profound. I don't think so. Apple Jacks be yum yum. What is he going to say that's going to be that impressive? Oh, shit. Now, let's see. Do you have any evidence that atoms orbit the way they describe it to you behave? Well, that's a great sentence. Let's see if I can do this. Do they have evidence that atoms orbit like the way they describe it to behave? No, they don't have any evidence whatsoever. They have evidence that they're in these distances from the center of the nucleus, okay, that the electrons are stuck in some, position, okay, distance-wise from the nucleus, and that's all they have. And they think it has to make a quantum leap to go from one distance to another distance, and that somehow it makes that leap without going any speed. That it just poofs into these energy levels. Now, at first argue they have the energy levels backwards. I mean, obviously, if you were to think about energy, you'd say that Mercury is the high energy level and Pluto is the low energy level. Doesn't take much work to get Pluto out of the solar system. It's going to take a lot of work to get Mercury out of the solar system, per unit of mass. Okay, you're talking about like 1,000,000 times more energy to get Mercury out than it takes to get Pluto out. They have it exactly the opposite. They think the strong force is on the outside and that the weak force is on the inside. And it's just really fucking dumb. All right, continuing.
Talk about language or numbers or mathematics. It's a really interesting thought experiment, but Feynman said, and I'm paraphrasing his exact words here, but his answer to this question was that if he had to pass one sentence to some generation that had to rebuild everything and they had no knowledge of any modern science or anything, that he would basically tell them that
for a little savings, Specialist Miller buys in bulk. For a lot of savings, she bundles her home and auto insurance with USAA. Putting more money back in her pocket?
Right? I mean,
that's what we're made for. Call for a quote.
Tacky commercial, that he put on his own video. What the hell happened?
That everything around them is made of these tiny structures called atoms. They can...
Okay, so this is the big... Oh, how the fuck did I go back? This is what Feynman would say.
Connect together and make more complicated structures, which make everything around you, like water and air. They can also be broken apart, and these atoms actually are constructed of even smaller things on the inside. Now, of course, he formulated it into a more...
Oh, isn't that just so... Yeah, did it knock you right over? Wow, that's so profound. Wow, that's the thing I would tell people. There's no really reasonable advice like, don't listen to your penis. It'll just get you in trouble. I mean, that would be really useful advice. Let's see. Okay, nothing new in the comments.
Beautiful single sentence, but that's the main idea. Because when you think about it, all of science up until the invention of chemistry, was really kind of going in different directions, trying to see what matched with everything that we had around us. But it was a huge leap of faith to understand that the oxygen in the air, the iron on the ground, the hydrogen, the oxygen, all of these things are fundamental, but you combine them in different ways and you get matter. You get different kinds of matter. And then you understand that those are further made of things.
Well, whatever. So this wasn't a leap of faith. It was a consequence of experiments, and obviously they did lots and lots of experiments, and then all of a sudden physics stopped doing any real experiments and just started contriving bullshit like, you know, the interstellar moron guy with the gravitational waves who invented the idea that matter turns into bent space. Doesn't turn into photons, doesn't turn into particles flying. No, it turns into bent space. Bent space. Bent space.
Even smaller than them. So atoms are incredibly important for our understanding of modern technology, and in some people's minds, fundamental to rebuilding civilization if you had to do it with a single piece of information. Now, before I dive into how long atoms actually last, I'd first like to talk about where they come from. So it's a story that begins with what we call the Big Bang, and it continues in the hearts of stars, and it even happens in our most advanced laboratories. So this is not going to be an entire lesson on the Big Bang, but I do want to touch on it a little bit because all of the atoms around us really are coming from that event. And
so that's just bullshit, right? I mean, that's not how all the heavy elements weren't created in the Big Bang. So, you know, what a pile of shit. And the very idea of the whole Big Bang is just, again, that's a story they tell, all right, based on a silly notion that the microwave background radiation is somehow light that didn't escape the Big Bang. It's somehow still stuck bouncing around for some reason. I mean, it's ridiculous fable they tell. But there's, you know, there's no reason to disbelieve it. There's no reason to believe it. There's just no good evidence indicating there was any original universe. And as we look deeper, right, they got the new telescope and they looked further and they saw more stuff and they found out, ooh, it doesn't look any more primal. They're not finding things that are primal. They're not finding like a deformed galaxies and all that kind of crap. They're finding the same active universe that they can see, you know, 2 or 3 light years away. It's the same universe, you know, 13 billion light years away. So the current evidence is not very supportive of the idea that there was a primal event. It's what's becoming apparent is that the universe is in a steady state. Gravity is compressing things and supernovas are ejecting things, and that's pretty much all that's happening. All right, continuing.
Continue to be produced inside of stars. So in a nutshell, the Big Bang is not just an idea that scientists just put out and say, oh, hey, I just want to like think of something that maybe could have explained everything. It's actually a mathematical theory that comes from observations. And that's what a lot of people don't really realize about the Big Bang. There's tons of evidence that match up with exactly what we see in the universe today. So when we look out into the universe at night, we look at all of the galaxies.
So, okay, so look, part of what their theory is that this explosion, right, that's what a bang is supposed to be, is an explosion, that somehow the light little particles didn't go fast and out of sight. They hung around for some reason, okay, which is silly. And the rest of it that spread out, it didn't spread out evenly over time. So in the first 42 milliseconds or something, it went from, you know, this big to instantaneously 4 million times bigger. That's in their theory. I mean, they draw pictures of it where, you know, it did this and then it's slowly doing this. You know, it's slowly expanding. You know, it's just horseshit. And there's no evidence of this expansion. There's no evidence that space is being created every day. A bunch of space is being created between my atoms, and there's no evidence of any of that horseshit actually happening. It's just a story they made up. A fable. A silly, talking Big Bang fable. I mean, it's just a fable.
and all of the stars in our galaxies and all of the galaxies that are outside of our own. And we see that all of the galaxies are rushing away from us.
So again, we don't see any rushing away. All we see is light being retarded by the fact that actually it has to go through substances. The universe isn't void of all substance. All those stars and the Milky Way, all this clouds of nebula and all this other kind of crap, the light has to travel through all that noise. And traveling through that noise means it's going to hit hydrogen atoms. And every time a photon hits a hydrogen atom, it loses a little frequency. That Compton proved this. All right, so this is proven science. All right, that the frequency of the energy of a photon is degraded as it interacts with matter. And we can see it in our own experiments in terms of pushing photons through matter. They don't go as fast. So they're obviously doing a lot of interacting. So it is just bullshit. All right, that's good of you to tell me. Thank you. All right, so I wish other people were that responsive to any of those differentials. See, I don't know why that is true, though. That's the part that's irritating. The mic is dull. I have to concede. I don't know why, but I have it boosted and I don't want to really change it. So I can certainly reduce that by 1 or 2, and I can boost this a little bit. We'll see if that's better. Oof, it's just a messy business. I'll turn him down a little. See, I can barely hear him.
And that's something called Hubble's law. The galaxies are moving away from each other. Not just that they're moving away, but the distance they are and how fast they're moving away from us are related. And if you go back in time to trace back to some prior position in time, then everything would be closer together. Presumably everything would be right on top of each other. So there had to be some situation when everything was on top of each other. And the postulate goes that there was a big explosion and all the matter and all the energy was created. So we can see the galaxies moving away from us. So we know that everything had to be on top of each other in the...
I mean, like I said, right here at the beginning, it does this huge, giant blah, boing, and then it does this thing, and then they're saying it's somehow the speed of the, expansion is somehow increasing. Bullshit it is. So again, they're just making this crap up. We have no evidence of this primitive universe existing. And frankly, with the newer telescopes, we're starting to see pretty far back. So again, just bullshit.
Distant past. But beyond that, we have done mathematical models to predict how much energy must have been released in the Big Bang, right? And the theory goes is that as space and time expanded, and the galaxies are rushing away from each other, it's not just that they're moving through space. Space itself is being stretched and created as the galaxies move away from each other. And if the Big Bang happened, and if it had
Oh, brother. Oh, they didn't make another one of those movies.
This world goes much deeper than you imagine.
Yeah, no, I can't imagine. Who the hell cares? Oh, they have, whalotons or whatever the fuck they're going to make up. Some other creature to play with. The movie really didn't age well, for me personally. Just because it was colorful and stuff happening, you could watch it a couple of times, but yeah, a couple turns into enough. But anyway. Where was I? Oh, I have to get rid of the commercial. That's where I was. Skip.
X amount of energy at the moment of creation at Big Bang right there. And then if we fast forward X amount of billion years to where we are today, then we should be able to look in all directions and see some sort of radiation that's left over from the Big Bang. It would be kind of like if you had, fireworks and they exploded. Well, the hot embers are going to be in the sky, and we would observe them and maybe even...
Okay, so obviously that can't happen. You're not going to observe hot embers in the sky. The stuff that goes really fast isn't going to be hot embers anymore. So that's not going to happen. And you're not going to see photons that are running away from you. So that's impossible. You're not going to see any photons that are going away from you. So how could all the light stuff be possibly visible? That would be impossible. Photons couldn't be visible because they're going to leave first. And there's nothing for them to crash into. Do you understand? They're way ahead of all the matter bits. So how the fuck can they crash into anything? They can't crash into anything and bounce back. So it's just silly crap.
On the ground, and you would be able to see their temperature, and you would be able to predict, okay, well, they must have been together with some energy before if we see these hot objects on the ground. But in our case, we're looking at galaxies moving away, and we're looking around, and we discovered that there's...
All right, so this is the funny part, right? Because they think the heat in the universe is somehow it never dissipated. So if the Earth got hot 4 billion years ago, it's their theory that it's still hot from 4 billion year old impacts. That somehow it got hot 4 billion years ago and it hasn't cooled down. There's no release of that energy. So there's absolutely no evidence that we can create any device ever that could actually be a thermos. You know, that would be a forever thermos. There's no insulating material. There's no ID. You just can't defeat the dissipation of the energy because even in a vacuum, you're creating higher energy photons. So if you're hot, you're losing your energy because you're forcing photons to increase their frequency. And the fact is that's going to absorb your energy. So all the electrons bouncing around off the surface of the sun, they're pushing on the photons that are coming into the sun. And they're increasing their frequency. And that's why we see the sun burning, is because we're turning infrared photons into visible photons. That's what the sun's doing. It's converting the cosmic background radiation and all the radiation we can't see, and it's converting it into visible light because it's doing this all the time. Yeah. It's pushing faster out than it pushes in.
Radiation in all directions, more or less uniform, and it has exactly the right energy, or we call it the temperature of the radiation, that would be in alignment with the age of the universe. If you work it back in time to the moment of the Big Bang, the energy of the Big Bang, as it expands, it cools off. The radiation, the wavelength of the radiation changes. Now it's microwave radiation. And when we look in the sky, we...
So this is the bullshit part, right? Because they just draw one picture to confirm the other picture. They just, oh look, this picture looks just like what we predicted. Well, yeah, of course we drew it to the prediction. You know, there's no like, oh, it matches the evidence. No, it doesn't match anything. It's just bullshit.
See exactly the correct frequency of...
I can't believe he's doing all this in a video he titled, you know, where do atoms come from? This has nothing to do with atoms, making atoms. Gravity is making atoms. It's mixing atoms.
Microwave radiation that the mathematical models predict we should see if the Big Bang actually happened. So it's really not that, you know, it's just an idea that we like made up and created. It's observational. We look around and we see this everywhere. And it's exactly consistent with everything being on top of each other with an explosion of time and space and energy of a certain energy. But that's not all. Because we can...
So all made up, and all this energy is calculated by the, mv squared. So it doesn't have anything to do with conservation of momentum, so just bullshit. Complete bullshit. And he's talking like this is something, he's not going to show us. He's not going to prove any of this shit. He's just going to say this shit. And everybody's supposed to just believe it because he says so. I mean, it's just so... It's such junk science. Let's see. Big Bang never made sense to me. Yes, likewise. I mean, it doesn't, like I said, it doesn't bother me either. But it just seems to me I can't really imagine this explosion that would do anything but reconsolidate and reconexplode. Just like the supernova and the rest of it, all of it would just recondense and that would be it. I've not seen it. I mean, it's also impossible to make this. All of the universe has got the same density to it. It appears to be of the same density. There's not, layers of thicker density. How could you have the same density of material with an explosion? It's just not possible. Nuclear bombs don't work that way. Nothing works that way. It's not an even amount of density. Let's see, I'm not seeing an ad that made me care what they were selling. Well, obviously, I mean, some are just so bad now. I mean, they're just so, they're just preying on morons. And you're just like, why does YouTube, it should be illegal to be stealing people's money. They're such they're selling some puppy, some mechanical puppy. It's an absolute fucking $5 stuffed animal, and they're selling it like it's an AI perfect dog kind of thing. It totally fools veterinarians. They they don't know it's a robot. I mean, it's just such a lie. You're just saying, how can they publish shit like that? And why would decent people want those ads on their video? Is everything light? What the fuck are you talking about? No. Force. Light's a force. Forces all go the speed of light. So gravity, magnetism, all that stuff is little bits of stuff that never stops moving. And electrons and protons are matter. So you have to understand it's two kinds of things. Stuff that's always moving and stuff that gets pushed around by the stuff that's always moving. That's why you say things like twice the force, twice the motion, because the force causes the motion. Oh, crap.
Look around, and we can also look at the abundance of the elements in the universe. You see, it's not just like an idea of an explosion. We can calculate in the Big Bang model exactly how much hydrogen should have been created, exactly how much helium should have been created, how much lithium, and so on. And then over time, those elements are attracted together, they form stars, they undergo nuclear fusion, and you make heavier and heavier elements all the way up until about iron inside of stars. Then you have supernova inside of stars, and the supernova explosion makes the elements heavier than iron. All of that is not just an idea, it's mathematical.
Okay, so again, but this is just bullshit to sit there and pretend there's some mathematical formula that demonstrates how these atoms are combined into each other. And again, this is in the context where they're claiming they can take energy from all of the atoms being made all the way up to iron. From iron and the rest, you have to break the atom to get energy. And all the atoms less massive than iron, somehow they actually believe that in forming those atoms, you get free energy. You release energy. And you really don't. It's bullshit. All nucleuses are energy. It takes energy to make one. They are the absorption of gravity, essentially. They've been pushed into an arrangement that's highly efficient.
Models. We can predict if the Big Bang happened, how much.
It's highly pressurized. If I put a proton, an electron, and a proton, that's a highly pressurized object. If I can kick that electron out, I have two protons really close to each other, and it's going to create an awful lot of motion very quickly. That's the pressure inside the nucleus. And it's a lot of pressure. You need a lot of pressure to create that arrangement of proton, electron, proton, to get them close to each other. And they already know that if I take a neutron, which is just a proton and electron that's been really compressed right next to each other, and I pull it out of the nucleus, it will fall apart and become hydrogen, essentially. It won't become something else. It's not like the electrons and proton will just fly away from each other. Obviously, they're close to each other. They're going to stay close, so they're going to become a hydrogen atom. And that's a very unstable atom until it meets another hydrogen atom and they connect to each other. Then you have a very stable. So hydrogen 2 is really the hydrogen that they use, to go in space and do all this shit. It's hydrogen 2. There's two molecules of hydrogen stuck to each other. I mean, the simplest way to describe it is just, it's just so obvious. You know, it's so polar. It matches so well. You know, this is your hydrogen atom, and the simple argument that is, if you can do this, okay, you can make a very stable form of hydrogen. You know, where they're going to stick to each other. Oh, the little Valerie's in the way. Little pain in the ass, punk. That's very stable, and you can see it's like from every angle it's very stable, and so that's the durable hydrogen.
How much hydrogen should we see? How much helium should we see? What is the ratio of all of these elements that we should see in the universe? And you want to guess what? We look out into the universe and we see exactly the correct ratios. Not just the ratio of hydrogen to helium, but all of the isotopes, which means the elements that have different amount of neutrons. So what
I mean, this is just such shit talking that they can do any show me. They can't do any show me math. Bullshit.
I'm getting at here is a little bit of a side tangent, is that the Big Bang not only predicts, you know, the galaxies moving away from us, not only predicts the microwave.
Obviously nonsense, right? They're not moving away from us. Everything's moving away from each other, okay? And it's just nonsensical. How could I be moving away from the stuff that's also moving in the same direction that I am? I can't move away from it if I have the same velocity. How do I move away from it? I can't move away from it. How does the Big Bang explain that? You know what I'm saying? Obviously the explosion would create an electron or let's say a piece of stuff in an explosion, and there'd be another piece of stuff 2 feet behind that piece, and they'd both be going the same velocity. And you say, how could they possibly be running away from each other? They're going the same velocity. Big Bangs don't explain expansion in the way they're describing it, where everything is running away from everything. That's not any explosion theory. I mean, they're just so full of shit. I mean, this exaggeration that they have proved any of this crap.
The background radiation that we see everywhere, but it also predicts what kind of atoms were created and the exact ratios of those atoms.
Yeah,
and when you look around today and observe the universe, those ratios are exactly what we see. So all of these atoms, as we start to talk about, do they last forever? Remember, they all ultimately came from the Big Bang, and then through stars fusing, and then through supernova explosion. So every element that you see has come from one.
So he's just talking shit, right? Because he can't even explain the obvious, which are the very small atoms were created in the Big Bang, maybe. But there's no reason to think they're not being created in the sun right now, that the sun isn't. They're talking about the fusion of hydrogen into helium. Well, what do I need the Big Bang for if the sun can make helium? What do I need the Big Bang for? I mean, it's just bullshit. Absolute bullshit. There has to be more than the Big Bang. Why does there have to be? There's no reason to think like galaxies, for example, are evolving. There's no such thing as, well, there's a very young galaxy and there's a very old galaxy. It really isn't happening. There's really no evidence of that. So the idea that all of this stuff just does this, you know, swirling, and it really doesn't ever cook into anything. There's no galaxy that becomes some kind of supernova, right? I mean, logically, if the galaxy was collapsing, eventually it would collapse into this gigantic thing that would have to explode, blah, 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 and it doesn't. So it's all bullshit. Yeah, it's clumping and exploding, but it's only exploding in a very exact way. That is, suns explode. They don't get bigger, right? There's a maximum size that a sun can be, and that's it. And it can't get any bigger. So those are rules that exist. There's no sun that's the size of a galaxy, right? So that's the rule. That's the machinery. So we know that the elemental machinery of the universe is suns. They're doing all the work. The substance of the work. I mean, the idea would be is that the Earth is eventually going to be part of the sun. Jupiter is going to be part of the sun. Eventually, all of this stuff is just going to be fuel for the sun. We're just lingering. We're taking a while to become part of the sun, but we're going to become part of the sun. I mean, that's the truth of it. And then the sun's going to say, I hate all this heavy metal, and it's going to barf the whole thing back into little tiny pieces. And it'll wait 10 billion years to reconsolidate. I mean, I'm just saying, they're talking so far past their evidence.
Of those events.
And Doug.
Imagine if we could tell everyone here that Liberty Mutual customizes car insurance to save people hundreds.
All right, you're going to save me money while you give Google billions of dollars in advertising.
So as I
revenue.
mentioned briefly,
So
most of the atoms around us...
They're going to give me a really great rate while they spend a ton of money on commercials. Silly, stupid commercials. Oh, okay, sure. That's the way. That's the company I want. The one that spends a huge amount of money on fucking Google ads. Yeah, I don't think so.
Were formed in the heat and pressure of dying stars, the heavier elements anyway. And when the massive stars explode in supernova, they create and scatter the heavier elements throughout the universe.
So again, they say that what's going to happen? Our sun is just going to become some little dwarfy thing or something. It's not going to nova, But I would argue that if all the other planets fall into it, it's probably going to nova into something. But whatever.
Generally, the heavier the element, the more unstable the element. For instance, every single atom of iron in your blood, in your body, was once part of an ancient star. It only can be created inside of stars. So you are literally made of stardust. Now, the interesting thing about this, if you want to get philosophical, is that when you look up in the sky, you only see the sun. That's the closest star. There are no other stars right on top of our solar system, only the sun. Right? And of course, it's undergoing nuclear fusion, and it's producing heat and light, and it's converting hydrogen to helium, and so on. So where is the iron? Where did the iron come from that's like in my body? Or where's the iron that's like in the asteroids that are hitting the Earth?
All right, so I don't know if they've ever tried to measure how much iron is coming from space, but I would guess it's none. Okay, so you could sort of argue that this nova thing is just the suns are so far from each other that it's pretty impractical to imagine that any of the heavy elements could have enough momentum to actually get to another sun. So it doesn't seem like a very good argument from my perspective. But I've never even heard about them detecting atoms in space, collecting them. And the only thing I've ever heard they can collect are hydrogen atoms. So that's all they collect. They put a collector of sticky tape up there and say, let's catch atoms. And they don't catch anything. They catch helium nucleuses, which are the cosmic rays, and they catch hydrogen. They don't catch iron.
In the ground. Where did that come from? Because I'm telling you that inside of stars, only elements up to iron can be created. Anything heavier than that had to be from a supernova explosion.
So again, they say it had to be. They don't really know. So again, more bullshit. But whatever. Again, it's their energy theory is based on mv squared. So all of their calculations regarding how much energy it takes to do anything is all distorted by the fact that they're making this huge miscalculation of the actual energy of these little pieces of crap. So I'm just saying it really is garbage.
So that means that before the sun formed, there had to be one or more other stars that already lived their entire life cycles and then exploded in a supernova.
All right, so that's the bullshit. I'm just saying that what it really looks like is that the supernova explodes, and then after 3 or 4 billion years, it just recontracts. All the little light stuff gone, but all the heavy stuff just ends up gravitationally being sucked back into the same pressurized environment. where's the evidence? I'm just saying there's just so little evidence to say, I mean, this stuff has to be constantly coming into the solar system, and it has to be coming from all directions. So the solar system's a disk. So obviously we have a clear view up and down where there's no other planets to collect any of the dirt. So why aren't we getting hit by a ton of dirt, okay, from all of these supernovas?
Making the heavier elements, iron and heavier, which then coalesced to form the rocky planets of which you are made of the same
Says
stuff.
you.
So when you look around, you know, it's like, where did this come from? Well, the interesting thing about it is there had to be another star system present before this one, before the one that we're actually living in now, another star, to form any of the heavier elements in your body. So the heavier elements are made in stars, but actually humans have learned to create atoms too in what we call...
All right, so all this is just so far off the subject, you know, that gravity is making atoms, but whatever. You know, it's making nucleuses. That's it. You know, the nucleus is stable. It doesn't need the electrons, frankly. It really doesn't. The nucleuses don't need the electrons. It's just that they're automatically going to collect them. So as soon as you put them in any environment where they can steal electrons, they're going to steal them.
Particle accelerators. So scientists smash atoms together, literally ram them into each other, and they create new elements that have never existed before. Now these synthetic elements help us understand the fundamental laws of physics, and they push the boundaries of what is possible in chemistry. So let's start with the shortest lived atom ever discovered. It's called tennessine 294. Now this is element number 117 on the periodic table of the elements, and it's a super heavy element, so it's very unstable. The nucleus just spontaneously decays, so it exists.
So nothing spontaneously happens anywhere in the universe, so a physicist really should train their brain not to use the word spontaneous, because it's an insult to the entire concept of the function of the universe. Nothing can happen spontaneously or randomly. Okay, these are not scientific terms. And it's, you know, this bullshit, you know, he's probably going to say it, but I mean, this element only lasts for 1/1,000,000,000 of a second. So, I mean, it is sort of just bullshit, you know, that you're arguing you saw the 1/1,000,000,000 of a second existence of the, whatever, xenocon. Bullshit you did. All right, Earth gets 60 to 100 tons per day of space material. I'm just saying, where, from what, the sun? I'm just saying the sun is spewing a whole bunch of material, but I'm just saying, where's the evidence that actual space is pushing a bunch of heavy metals into the solar system? I'm just saying, I've never heard of them collecting any heavy metals in space. So if you're saying empty space is full of heavy metals, you know, that's a pretty bold statement, right? Because that means light is even in more trouble when it travels through space. If it has to travel through a bunch of heavy metals, heavy atoms are really going to fuck up a photon. So, you know, you can say what Google says, but yeah, I need a bigger answer from Google than that. Earth loses roughly 90 to 100 tons of mass daily. So again, you know, these arguments are crap. Yeah, okay, that's what they are. They're crap. Exactly how does it do that? I mean, even if you look at all the layers of the atmosphere and you say, okay, helium's buoyant and it goes up to the surface, why would it leave the Earth? It's still being compelled by gravity to keep bouncing around outside the Earth's atmosphere. It doesn't have any incentive to leave. How does it leave? How does it get enough energy to leave? All right, it requires further study, but people do monitor this stuff. And Earth plus Sun moves through a lot of space per year into zones. Yeah, well, it doesn't matter. I'm just arguing that realistically, I just haven't heard any argument made about, I mean, hydrogen atoms are rare in empty space. How rare are iron atoms? And iron atoms with momentum that can actually get to the Earth. Yeah. So I'm just saying, it sounds kind of like bullshit.
for only 78 milliseconds before breaking apart. Now that's faster than a hummingbird's wing beat, but it's not alone in its short-lived nature. Scientists have also created dozens of synthetic elements that exist for mere fractions of a second. Now these super heavy elements, again, the ones that are near the bottom of the periodic table, they're pushing the limits of what we can do in science. They're so massive, the nucleus is so big that it's just not very stable. And the electromagnetic repulsion between the individual protons in the nucleus, it's overwhelming the strong nuclear force that's there present because of the protons and the neutrons. So literally it breaks down.
So the strong nuclear force is just the biggest bullshit, lie, fable, nonsense. I mean, it's one of the biggest. Oh, fuck you people. You can't think at all, right? I mean, they can't think outside of their fable at all. Because, I mean, even in Maxwell's time, he already gave you everything you need to understand why you don't need a strong force, right? I mean, I want to get two protons. I want to get two positive charges close to each other. What do? What's the simplest way I can get two positive charges to get really close to each other? What's the simplest way I could get, you know, I have a north-south magnet. Okay. What's the simplest way for me to get two north magnets really close to each other? Oh, yeah, here we go. Right there, right? Yeah. I've got the two north side magnets really close to each other. I mean, I mean, this was done in the 1800s. They already had this mechanism that's perfectly sensible to understand how I get two protons close together. I just put a fucking electron there. And they already know that a proton decays into an electron and a proton, right? So you already know that this combination is essentially a proton. So obviously the nucleus has protons, which are electrons and a proton, and then extra protons. So it has a 2-to-1 relationship, two times the protons, one electron, and we know that the rest of the electrons are here. So we know we have the same number of electrons and protons in the universe, that this is how you construct an atom, and there's absolutely no need for anything called a strong force. It's just complete nonsense. This invented fake force. No mechanism, no theory about where it comes from or how it works. I mean, except the frog theory. I mean, their theory is there's some frog particle that shoots its tongue out and, you know, grabs the proton and pulls it towards the other proton. I mean, it's ridiculously silly. And they talk with this arrogance, like they have solved the universe. And they're so far from getting it right. Oh, God, I wish the aliens would just come here and embarrass these people. It requires further study. Okay, yes. The fact that the Earth loses mass every day used to scare me as a kid for some reason. And again, I'm arguing, where's the evidence that it's losing mass? I mean, that it really has the capacity to create enough momentum to create escape velocity. What is escaping at escape velocity? I mean, what atoms are moving fast enough away from the Earth to achieve escape velocity? How? How are they doing it? Explain it to me, please. I just can't understand how you're saying this is possible. To get away from the Earth, it has to go through the atmosphere. So if I take a helium nucleus and I try to shoot it, I can't give it enough energy to leave the Earth. So there's no way particles that are on the Earth are decaying into space. It just ain't happening. Yeah, it's mostly gases. I'm just saying. I don't have to look up anything, you fuck. I'm saying quite simply, the buoyancy of helium. Do you see how fast the helium balloon rises? Do you think that's enough momentum that it can escape Earth's gravity? Do you really think so? The helium is going to escape Earth's gravity because it's going to go so fucking fast. No fucking chance. I'm not interested in Wikipedia or TED-Ed or, you know, Google says or any of that horse shit. So whatever, just, you know, take your argument. I'm making my argument. I'm saying until I see any evidence of them putting a detector, a satellite in space, and the satellite is collecting matter coming off of the Earth. Show me that experiment. Show me the matter being collected by a satellite. Because there's just no source. Nothing is making enough energy to escape Earth's gravity. I mean, you could argue volcanoes maybe, right? A volcano might be able to create some particles that could actually escape at a high enough velocity. Is there anything else you can imagine that could possibly create an escape velocity? What is this crap? Anyway, someone should make an article for Emendum. What the hell does that even mean? This isn't the Emendum channel. Include Draft Science channel, which will give its publicity. Yeah, whatever this article thing is. Yeah, somebody should do that. Yeah, somebody should make me famous. You know, without, you know, beating me to death with a hammer to make me famous. All right, so anyway, just absolute bullshit.
Because of the internal force between the protons pushing apart. So I want you to try.
So just understand, the simplest way to get two positive charges close to each other is to put a negative charge between. Happen every time. Take two positively charged fluff balls and say, I want to get them close to each other. Well, then just stick a negatively charged fluff ball between them and they'll stick right to it. No problem. I mean, it's such an obvious answer. Strong force, bullshit. And Rutherford actually believed this. I mean, this is the part that's kind of disgraceful. Is the guy who invented, you know, who found these particles, actually said nucleuses have electrons in them.
Try to imagine holding together a house of cards in a hurricane. That's kind of like what these atoms are fighting against.
All right, so they really aren't, because their geometry, that's why there's only 100 of them, right? There's only, whatever, 80 stable ones or whatever. Is because the geometry is rigid. You know, it's very rigid geometric magnetic relationship they have to each other, the electrons and protons. And there's only so many geometric shapes you can make that will sustain, that will be able to survive outside of the pressure of the sun. All right, they understand how this oxygen loss happens on Earth night side, but they're not sure how it happens on the day side. Well, I'm just saying, how does it even happen on the night side? I'm just saying, your required atoms are all affected by gravity. I'm just saying, so you have to give them enough momentum to have escape velocity. Do you understand? They have to have enough velocity to achieve escape velocity. And there just isn't enough energy, you know, in the top surfaces of the atmosphere that could possibly be creating ejections. All right, NASA's Earth Observatory program called Visions 2. Well, they have 14 million stupid projects doing all kinds of stupid shit. And it's all stupid shit. Anyway, visualizing ion outflow via National Atom Sensing 2. Not arguing, just looking for truth info. Well, again, you're not going to find it by them telling you what it does. You have to actually look. They can't describe a two-slit experiment accurately. You think they're going to describe to you what their fucking goddamn observatory is actually observing? Get real. They think the Stern-Gerlach experiment, rather a famous experiment, they shoot silver atoms by heating, well, they use cesium now, heating it so it's ejected off the surface, real silver atoms, and then they say, we're measuring the spin of an electron. I mean, it's such fucking nonsense. Okay, let's see. Okay, yeah, we're done with that one. All right, back to the video.
Now, inside of every nucleus, we have protons and neutrons,
Yay.
and we have the strong nuclear force that exists trying to hold those together. but at the same time you have repulsive forces between the protons. So the strong force is the strongest force in the universe, in nature, but it has a catch. It only works in extremely short distances.
It's so magical. It's more magical than dark matter. It's the most magical force we've ever invented. It's so magical. What's with all
You
these
probably
ads?
learned when you were young.
I mean, so I'm just saying, obviously there's absolutely no reason to make up this fake force and then say, oh yeah, well, realistically we can't make any sense out of it because we don't know where it came from, so we have to limit its scope, and so it only works, 4 distances of a proton and then doesn't exist anymore. So it's just this magical mechanism that magically does something, and it's just such a pile of shit. And if they just colored this correctly, right, the blue things are electrons and the red things are protons, they would solve their problem. There are no neutrons. Neutron is just a word. They're describing an electron-proton pair. So if they just acknowledge that neutrons aren't necessary, they can understand nucleuses by just saying it's electrons and protons. And because the protons are heavier, they're stuck in the nucleus with half the electrons, and then the other half of the electrons can be stuck in positions around that nucleus. That nucleus that has obviously multipolar, in the sense that it's going to have magnetic poles in more than one direction. It's not going to be dipolar, it's going to be tripolar, zipolar, it's going to have more than one direction of polarity. And obviously the electrons are going to see that and be stuck in positions. I mean, they have atoms so wrong.
That 2 positively charged protons are constantly repelling. The nucleus is full of positive charges, so it should explode and fly apart. But actually, the strong nuclear force between the neutrons and the protons is the strongest force and actually overwhelms that repulsion and holds it together, but the strong force only acts over short distances. So when the nucleus gets too big, it begins to become unstable again. That's why the heavy elements break down.
Made up baby talk. So again, no explanation other than they say so. Obviously, all these atoms are made out of the smaller version, right? I could argue that deuteron thing, or the helium nucleus even. You could just say you're just adding helium nucleuses to go from one atom to the next atom to the next atom to the next atom. And that's all you're doing. So it's all made out of the same building blocks. And you're just arguing that once they get to a certain geometry, they can't make the hexagon anymore. They can't make a symmetrical object, and it's too non-symmetrical, and that's what means it eventually it's possible, like in the Star Wars Death Star, it's possible to hit its vulnerability. It has a spot where if the right energy hits that spot, it's going to break. And the simple idea of breaking just means that enough energy hits this magnet to knock it free, and then the other 2 magnets will see each other and run away.
Radioactive. So the interesting thing about this is that we think that the protons and the neutrons each consist of 3 quarks inside, and the strong force originates there and kind of leak outside of the boundary of what we call the neutron and extends outside. So they come from the quarks and they kind of leak outside of the boundary, and that additional leakage is what actually provides the strong force between the protons and the neutrons in the nucleus. Now the strong force is weird all by itself because it's totally different than anything we experience in everyday life. So gravity, for instance, it gets weaker with distance, right? Weaker, weaker, weaker as you get farther. But it never quite gets to 0 according to classical theory. And the strong force is more like...
Well, we know gravity is... I know. Gravity is actually made out of particle density, so there are places in the universe that just won't know the Earth ever existed. Okay, they're never going to sense any disproportion in their field from the Earth because of the fact that the inverse square law is reducing the density of the change in the field, so it's billions of light years across. The void of a photon is a million light years. Another commercial? Oh no, I don't think so.
Velcro. It only really works when the particles are extremely close together. beyond about a femtometer. That's 10 to the minus 15 meters. Outside of that distance, it totally practically disappears and it's non-existent. So outside the nucleus, the strong force doesn't appear at all.
So they just made up all that stuff. There's no evidence, there's no experiment, there's no anything. They're just making this shit up. And it's silly shit. Oh, God. It's so irritating being on this planet. Let's see. Also, apparently you can collect micrometeorites in rainwater. Well, I wasn't arguing about micrometeorites. They're obviously high velocity pieces of crap. It's been orbiting and it's in one of those eccentric orbits that eventually crashes into the Earth, because the Earth is in the right spot. So there's a whole bunch of dust circling, like Saturn. There's a bunch of dust still floating around, orbiting in the solar system. So we know where that energy came from, right? We know it didn't escape the solar system, so we know it's trapped. All right. Tiny extraterrestrial dust particles fall to Earth continually. So again, that's just bullshit. So I'm just arguing that, yes, that's the stuff in the universe. It hasn't escaped anything. So again, sort of bullshit. Alright, evaporate the water from the second dish, leaving behind the dark, fine magnetic dust. Use the strong magnifying glass or a microscope to examine the particles. What the fuck are you talking about? I'll give you a timeout if you're just going to be way too obtuse. And that's just way too obtuse.
Now this is where the concept of the nuclear valley of stability comes in. For each number of protons, for every element on the periodic table, in other words, there's an ideal number of neutrons that makes the atom most stable. If you have too few neutrons, and the protons push each other, and there's not enough strong force, and everything explodes and decays. But if you have too many neutrons, the nucleus gets too big and too heavy for the strong force to contain it. So both of these situations lead to an unstable nucleus, too few neutrons and too many neutrons. So there's a range of the amount of neutrons you need to be in a nucleus to make it stable. And radioactive decay is nature.
So again, the argument is obvious that the geometry is what makes it stable. The symmetries that you can create in the geometric form of the nucleus. And the less symmetry you have, that is, you have some, wobble, some distortion in its symmetry, you can expect that to be a problem. That's going to create a vulnerability.
Nature's way of moving atoms towards stability. There are several types of decay, each with its own fascinating properties. First, we have alpha decay. That's when a nucleus ejects 2 protons and 2 neutrons. Essentially, it's like ejecting a helium nucleus.
Right, so the decay products are different, but decay is the same thing. So they all are going to create some measure of these different elemental bits when it breaks, because the fracturing point for each one of these elements is going to be the same. They usually always decay into, like uranium into barium and plutonium or some kind of bullshit. So they always tend to fracture the same way. And so there's certain atoms that decay and create a lot of gamma, and then there's atoms that decay and create a lot of alpha particles. Continuing.
To become more stable. This is actually what powers some smoke detectors in your house. And then we have what's called beta decay. And that's even weirder because it actually transforms protons into neutrons or vice versa through the weak nuclear force. It's kind of like atomic alchemy, changing one element into another through a decay process.
My energy bill dropped from $150 to $50 by doing this. My friends laughed at me when I spent $49 on a power saver device that could cut my energy.
Too many commercials.
So the way this basically works is the periodic table is...
So again, this weak force bullshit is just that weak force bullshit. Obviously, if I break one of these objects, I can break it at a certain point. Say if there was a proton, electron, proton, electron, proton, I could break it at some point where, you know, there's a neutron on one side and a single proton on the other side. So there's lots of different ways you could fracture these elemental sticking pieces. And again, you can draw the geometry right here. I'm drawing you this simple geometry, of hydrogen 2. And you could really understand how it's just so simple. I mean, the two protons are repelling each other, two electrons are, but they're attracted to each other, so they're stuck in this arrangement. And they're in a very noisy environment, so they're jiggling about, you know, constantly. So they can't just close in on each other because they keep moving and seeing each other with different intensities, so they can never crush right into each other, and they can't crush anyway because the two protons really can't get next to each other, and the two electrons can't really get next to each other. So they really have to bind in a way where they can't see each other. If they can see each other, they're going to be repelled. The electrons can't see the other electrons, and the protons can't see the other protons. And that's what the sun allows you to create, is that environment where you push them so close together that you blind them to each other.
Organized by atomic number. As you go up and up and up through the periodic table, you're increasing the number of protons. So if you had a decay process that changed one of the protons into a neutron in the nucleus, then you basically lost a proton through a decay process. And so you've moved left on the periodic table, and you've basically changed from one element into another, and a decay product is shooting out as part of that process. And if you go the other way, changing a neutron into a proton, you moved right on the periodic table. Now there's also a decay process.
So again, that's their story, but I'd argue you're really just saying you have to break the geometry, and it's not as simple as just knocking one piece off of the atom. That's not going to, they don't decay that way. They decay by fracturing into two lesser atoms and a bunch of pieces. They don't just shoot one alpha particle and one this and one that. So uranium, for example, makes 3 neutrons fly out of uranium. So every time a neutron goes in and breaks it, 3 neutrons pop out. And that's what makes the chain reaction.
Process called gamma decay. That's a pure energy release, like a nuclear light show where excited nuclei release high energy photons.
Bullshit. So again, that's going to happen with every single one of these decays. Is going to create, you can't help but create it, because that's just electrons and protons, electrons moving. They move and they push on the energy already in the universe. They push on it and create high energy photons because of their high velocity. As soon as an electron moves with a high velocity, it's automatically converting all the energy that's coming at it into a much higher frequency. So the faster you move an electron, the more you compress the frequency of any energy heading for it. That's how you make a gamma.
To reach a more relaxed state. Now, the mathematics of radioactive decay reveals something really cool about
more made-up bullshit math. Again, they can't even get the math of energy itself correct, right? I mean, their math is a huge contradiction. You know, it violates the law of the lever, violates Hooke's law, violates all this stuff. They don't give a shit, you know. So you can't trust them on this subject if they can't even get something as simple as momentum and force. They can't even read Newton's clear statement: twice the force, twice the motion, 3 times the force, 3 times the motion. They can't read that simple statement and acknowledge their physics disagrees with that entirely. They're just so dishonest.
nature. It follows an exponential pattern that's found everywhere in nature, from population growth to all the way to compound interest that governs your bank account. And this mathematical beauty led to one of our most powerful dating tools, and that is called radiometric dating. Now let's take a minute and dive into what we call carbon-14 dating, because I know you've heard of it, and because I think it's a really cool and really practical application of radioactive decay that we actually use. Now, every living thing on Earth contains a tiny amount of radioactive carbon. That's just a slightly unstable version of carbon. It's constantly replenished while you are alive and eating things on the planet. Now, there are different flavors of carbon. These are called isotopes, and that's what the number after the carbon means. Now, all of these flavors, or these isotopes of carbon, they all behave the same chemically, but they have different numbers of neutrons in the nucleus. So they all behave the same chemically, but some isotopes are heavier than others and more unstable. So you're eating carbon all the time. Like when you eat anything, you're constantly taking in all of these different isotopes of carbon into your body. And when something dies, this replenishment stops because you're not eating any more carbon-14, and the carbon-14 that you have ingested over your life begins to decay. It's sort of like a cosmic clock because the decay is very regular over time. Very, very, very regular. And so if something dies, we can measure the ratio of how much carbon-14, the heavier version of carbon, is in there, compared to carbon-12, the more common version of carbon in there. And we can use that to date how long it's been since the organism died.
Right. And, you know, the catch, there's always catches. But you'd have to know what the metabolism
So you only check it twice?
is of the thing that was
Nissan tests
consuming
every
the
model
carbon.
thousands
So
of
you have to have
times. We've
some
been
way of
testing for severe
approximating
Now, just as a side note, a
what
half-life...
your expectation for the level of carbon-14 would be, because you're really, well, especially with stuff that doesn't exist today, it's pretty hard to say how much carbon-14 would I expect there to be in that thing that existed 200 million years ago or something. Well, obviously it's no good for a purpose that long. You can only use it for more short term, like within 10,000 years. Because in the old things, all the carbon-14 is gone. Yeah.
of carbon-14 that measures how fast it decays is 5,730 years. So it's good to date things up to about 50,000 years old, which is really good for studying anything in human civilization. If you find a fossil or a skeleton or whatever, general carbon-14 is going to be good enough to date it because it's in that date range, or it's about that old, right? But if you had something much, much, much older than 50,000 years, carbon-14 dating isn't going to be that great because basically, since the half-life is only 5,000 or 6,000 years, roughly, then if it's too old, like if it's like 5 million years old, then all of the carbon-14 will have decayed so much that you can't really measure anything anymore. So we have to use other radioactive dating schemes for even older objects. So we've talked about radioactive decay, and that's the thrust of this stuff. Do atoms last forever? But on the other end of the spectrum, we have some atoms that are actually so stable they might as well be what we would call immortal. For instance, there's...
Right, okay, so the interesting thing, again, I would argue is where's the new carbon-14 coming from? The sun?
Bismuth 209. That was long thought to be totally stable, completely, until scientists discovered its incredibly slow decay rate. One decay every billion trillion years on average. So why?
So you'd almost argue that, I don't know if they could even be sure of that because of the number of impurities that would be in their sample. So, you know, that's really reaching.
Is it that some atoms are so stable but others aren't? It's all about having the right number of...
Yeah, it's all about geometry, 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 geometry.
Protons and neutrons, what I mentioned earlier. So there's these magic numbers, and they really are called magic numbers of protons and neutrons that make some nuclei really, really stable. And atoms...
Right, 2, 4, 6, 8, 10, you know, that kind of thing. Yes, symmetric things are going to be more stable.
With these special numbers or ratios of protons and neutrons, like a perfectly balanced structure in the sense that they're very resistant to decay, very, very stable. But if you deviate farther away from that, you have more instability and more decay. So the natural thing is, if you're going to talk about...
You can almost think of this like in some kind of simple example, right? So if you're going to build something very small, it's very easy to achieve the symmetry. But if you're going with something very big, you'd have to understand that every time you added something to the outside, it would have to be made out of a lot of particles. And so it'd be very difficult to collect all of that at one time to create your symmetry. So that it's really unlikely to create symmetry on those outer shells of heavy nucleuses.
Atoms in decay, you might want to talk about what's inside the atom. Some physicists think that even protons, the building block of atomic nuclei, might eventually decay. And they're studying this right now. It's not a really resolved thing. The estimated...
It's just... Protons are elemental like electrons. They're not made out of anything. There's no quarks inside. None of that shit is real. Hit the button.
Half-life for this process is 10 to the 34 years. That's an incomprehensibly huge number. It's so long that if you've been watching a single proton since the Big Bang, the chances are that it would not have decayed yet. So the bottom line...
So why even bring it up, right? You have no evidence that it happens, and you're just making up a story that you don't have any reason to believe. And yet you're saying it like it's a real thing. Like somehow the number of protons in the universe can change. And that slowly over time, all the protons are going to decay and all the electrons will be left very lonely.
As individual protons are incredibly stable. The idea that protons...
Individual electrons are even stabler because they don't have any stupid quirky crap inside of them. Ugh, just so bad.
Do decay after an incredibly long time period comes from so-called grand unified theory attempts.
Whatever. So this is all again, they just make up this fake, silly story, all this complexity. It's not complicated. It's magnets, frankly. We're just made out of magnets. I mean, where's my magnet ball? That's it. We're just made out of magnets. We're made out of magnets. Just magnets. You know, this crap that's stuck to my magnets. But and geometry, right? So I mean, I can create a geometry. I can, orient these magnets into shapes and structures, so easily. And it's just electrons and protons. That's all it is. Electrons and protons. Geometry. North, south, north, south, north, south.
Attempts to unite all the forces of nature into a single framework.
For a little savings, Specialist Miller buys in bulk.
Commercials.
For a lot of savings.
I guess I just can't play his videos this way. I have to download them.
So the standard model shows that we have 4 forces of nature currently. Right? We have gravity, which is the weakest of all of them.
All right, so we know all we have is radiation in the form of stuff moving the speed of light. All the forces move the same speed, the speed of force. So we have forces moving the speed of force, and then we have electrons and protons moving very different speeds depending on how much force is interacting with them. I mean, it's so obvious. The Sisyphus-Boulder model works so well. The force is Sisyphus's. They push. They move the speed of light. When they're pushing boulders, they can't go the speed of light anymore because the boulder's heavy. That simple explanation does it all. And they just won't listen to it. It will be found to be the truth. I mean, they just won't hear it.
Actually. We have the strong nuclear force, the strongest. We have the weak nuclear force, which governs...
Made up. It's just all made up shit.
Radioactive decay, as I mentioned. And we have the electromagnetic...
The photon force. And the photon force is interesting just because it's the one where you can't see the other half of it. The only force we see is the electron, the force that affects electrons. We can't see the force that affects protons because it can't move protons enough for us to see the effect.
Force that governs attraction and repulsion between protons and electrons, and also photons of light, right? So
that's all it is photons, frankly. All electromagnetism is conveyed from one object to another object by invisible photons. Invisible photons are telling this stuff where it's going to be. Force bits.
Gravity is the weakest of those. Now, the idea is...
Right. The gigantic force that's moving gigantic planets around is the weak force. It's just ridiculous. Sorry, gotta do some maintenance here. Right, done with maintenance.
Is that it's kind of like weird that we have these four unique forces in nature.
Yeah, it's weird and stupid and nonsensical that the universe has all of this weird properties and does all this weird shit when a simple model can explain it all.
Nature. Perhaps they can be unified under a single theory, and when we look at these different forces, we're just examining them in different circumstances.
They all have the same speed. They all have the same speed. Gee, they all have the same speed. Even gravity is the same speed. Why should I think there's a bent geodesic when it's moving the same speed as light? Why wouldn't I think it's got to be made out of that light shit? It's got to be made out of the same stuff that's moving the same fucking speed. Why do I think it makes? Why would it make any sense that it's made out of some other shit that moves exactly the same speed? That would be just goddamn stupid. So obviously all this shit that happens at the speed of light must be all the same shit. I mean, it's so obvious. The logic is indestructible. They're all moving the speed of force. It's just a coincidence that these completely different mechanisms all move the same speed. Shit.
You know, it's kind of like water and ice and steam. You already know that water behaves totally different. You can pour it, you can, make you can make droplets out of it, throw it in the air.
Yes, you can change the density of materials, and water's the outside of that rule just because of the way it traps other, the way it arranges the oxygen. It traps air, I know that. But whatever. The point is its density decreases. Okay, as it goes into a solid form where everything else gets more dense, and so it's not very complicated. And the fact that that density would be dependent on how much they're jiggling, how hot they are, makes perfectly good sense. Again, it's these objects have to see each other. Electrons and protons have to see each other. If they're doing a lot of this, they can't get close to each other because they keep moving out of the force. The direct line of sight force. They keep changing how much force they're being affected by. So the more they're moving, the further away they get. And the less they're jiggling, the closer they get.
But it behaves different than ice, which is hard and solid, right? But that also behaves differently than steam, which floats around, and you put your hand through it. So if you didn't know any better, like just a little child, they didn't know what water was, they would think that water and ice and steam were totally different things, because one of them is hard and cold.
Well, I think everybody, I don't think anybody was confused by that, right? You can't even think of a moment where you didn't know that, water was at least ice and water, So, yeah, it's hard to imagine when you didn't know that.
And one of them is not as cold, but you can pour it, and the other one is like floats in the air, right? But actually we know that all of those are the same exact molecule. It's just that they're in different regimes, and that their different regimes are related to what we call temperature. So maybe these...
Yeah, what we call temperature, which merely means how much are they being agitated by force. Photons.
four fundamental forces of nature that we think look different are actually unified under some broad, overarching, grand, unified force. And really, when we examine things in the nucleus and gravity and...
yeah, that's right. All turns into thermodynamics. And what's the thermal part? Oh, photons. Sisyphus dynamics. Yeah, let's see. It's okay. I don't know what that means. Let's see. More BS. Google Images wave function in two entangled photons. Oh, I'm not going to talk about silly entangled, and especially entangled photons. It's just baby talk. I mean, if that's your thing, go ahead and waste your time. I've done a ton of videos on the subject. There's no entanglement. It's complete mushy bullshit. So anyway, I don't know what this "it's okay" means, and I don't know what "hopefully" is, so whatever. Don't know what you're talking about.
Electromagnetism, we're just looking at different manifestations in different situations. But maybe we can unify it under a common umbrella, kind of like ice is the same as water at the molecular level, right? So that's what we're working on in terms of unification theories. Now, these attempts at grand unified theories, they predict that at really high energies, like maybe during the Big Bang, all of these forces actually were unified under a single force, and protons become unstable. It's like discovering that the most fundamental building blocks of matter have a built-in expiration date, albeit one that's impossibly far into the future. So to put it mildly, it's really difficult to...
What the fuck? You know, they just make just like puppets. You babble, 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 blah, 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 blah.
To test this, because we can't travel back in time or even do experiments at such high energies, even with our most powerful accelerators.
One thing I've noticed about football fans is they all talk like the players can actually hear them.
Proud of you.
But when you have Geico Insurance, you'll always...
So we've gone on...
Makes you wonder about insurance, right? That it must be such a racket. You know, that they're so desperate to get people. They're so desperate to hook them. You know, what a racket it must be.
A few detours as we've talked about answering the question, do atoms last forever? And so let's circle back and talk about that diamond that we started the whole thing with. Remember that diamond? So if we give it enough time, and we're talking millions or even billions of years, that diamond...
You should know the difference. I mean, that's a big difference. Millions or billions.
...will gradually transform into graphite. It's the same stuff that's in your pencil. It's the same atoms. They're just rearranged differently. And so we'll go from brilliant and sparkly to dull and grayish and blackish.
Right. On the outside or from the inside out? That's the question I have. So if you're going to say yes, it's going to oxidize, so to speak. Yeah, sure, that makes sense. You're going to pollute it. The environment is going to pollute it.
But the carbon atoms themselves, they're just rearranging themselves into a new pattern of bonding with each other. And they give rise to how different diamond and graphite look and behave on the outside, even though they're made of the exact same carbon atoms on the inside. So, to answer the question, do atoms last forever? So the answer is kind of yes and kind of no. And honestly, I know that that's a wishy-washy answer, but it's really true.
Oh, whatever. So, whatever. I don't know if that was the question he asked. I don't know. You know, it was so many years ago when I started this video.
So some atoms do transform in the blink of an eye because they're so unstable, and others will literally outlast everything we know. And maybe they won't literally last forever, but they'll last so far into the future that it might as well be forever. They're a reminder that in nature, nothing ever truly dies. It just changes form.
Well, whatever that means, right? I don't know what die would mean anyway. So we know that he's talking about protons dying, you know. So whatever, you know, there's just no point in this babble. Obviously, I would argue you can't destroy Sisyphuses and you can't destroy boulders. So all you can do is just rearrange them. Period. Nothing else. There's nothing else to do.
And maybe that's more beautiful than lasting forever. So, the story of atomic stability is really the story of change itself. How everything in the universe is in a constant state of transformation, seeking balance and seeking stability, usually going from a high energy, unstable configuration or state into a...
Yeah, it's usually blah, 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 except where you decide to make, free energy by fusing hydrogen atoms, which it's not hydrogen anyway. None of these experiments they're doing are they actually turning hydrogen into helium. They're breaking some other material.
Lower energy or more stable configuration or state. From the smallest atoms in the universe to the largest stars, everything is connected by these fundamental forces and principles. I'm Jason. Thanks so much for hanging out with me today.
Oh, fuck you. No offense, but yeah, you're just talking shit. You're freaking molesting young minds with a bunch of crap you just made up. It's just a religion. So you've given your sermon, and I'm just going to make the rational argument that you don't have to believe that shit. There is an evolution alternative. There's a scientific alternative. One where you try to find a simple answer, not a silly answer. That's the goal, is to find the simplest answer, not the silliest answer. All right. Well, that was tedious and unpleasant. Yeah, that's all I can say, is that was tedious and unpleasant. Let's see if the old moonshine guy has made a new video. Too bad that I Can Science that guy has run away. He's not doing nothing. It'd be nice if he made some video preaching some more crap about how springs work. Alright, so that's it for that. Oh, I gotta put these magnets somewhere safe. I say we'll ruin stuff. Yeah. Where should I put them? Where's a place to put the magnets so they don't ruin something? Ugh, put them in there. Alright. Anyway. So, do I need to do much else? I don't know. I'll think about it whether I want to do anything else. So we'll see if the commenters have anything to provide, any insight, any interest, any useful, relevant remarks. 9 viewers. Okay, well that's about as high as I get, is that 9 number. We need to do twice that to really have a interesting give and take thing happen. So anyway, it's just there needs to be so many experiments need to be done, but I mean, they really ought to, somebody ought to be interested enough, some physicist ought to be interested enough in this whole mv squared versus mv thing to say, yeah, I'm going to go prove it takes 25 times the force to spin something 5 times as fast. Or, I'm going to prove, it takes 9 spring compressions to make something go 3 times as fast. Yeah. It's just so ridiculous. And again, I really wish I had the space to do experiments, but I just don't. And I don't have any instruments to measure anything. Yeah, I don't think you can fix Google's algorithm, so as long as they won't allow anybody new to see the videos, I'm sort of doomed. So, I'm hoping maybe if I can get, put more content on the website, that maybe Google will index the website better, but who knows. It's just so hard to, it's impossible, frankly, to properly network, because the convention won't allow it. I mean, every single message board I've ever joined, they've booted me out in, within 72 hours. Because you're not allowed to talk about this shit. is all very irritating. Yeah, well, fake views don't really appeal to me, I have to say, frankly. It's not my style. I'm not for it. Yeah, I know it's what the internet runs on, but yeah, it's not part of my white hat kind of ideal. You know, you can't fix it by breaking it. Left a comment on Universal Extinction's video. Oh yeah, well, who cares? Just obviously some putrid rag. I just thought it was hilarious that, you know, they're going to dig up all this evidence that I'm some horrible perpetrator, and he had, you know, this nothing 20-year-old stickam video. I mean, it's so ridiculous. I mean, those rooms, I would spend 8 hours in those rooms. 8 hours. You know, I mean, it was, you know, there were all kinds of lulls in the conversation. And, but anyway, it just, you know, it's just so ridiculous. Teaming up. Oh, what a, oh, how frightening. A team of what? I mean, that would be pretty funny if he found allies in what's basically a 10-member terrorist group who wants to blow the world up. I mean, that would be kind of hilarious, right? Yeah, he's going to join forces with the you know, I don't know, like I said, I guess they have some idea that they're going to seduce some billionaire James Bond villain, you know, to help them, you know, with their project. And then somehow James Bond isn't going to, you know, thwart them. Yeah. The whole thing is just hilarious. Your Ed article is still up and very old. I don't know what that means. The fuck's an Ed article? Please explain. What's an Ed article? I don't know what you're talking about. I didn't even know I wrote an article. Oh, yeah, that is really old. But I mean, you know, you talk about just real bullshit. I mean, there's just not a single sentence that has anything to do with the truth. Just is funny that that's all these people got, right? I mean, they can just try to do this some sort of character assassination, you know, so they can't argue with my actual arguments, and instead they have to somehow prove that I'm an invalid messenger, that I'm somehow, you know, because of my character defects, I can't possibly make a physics argument. Oh, no, that's not possible. But somehow the physics is corrupted by my poor moral character, and my poor moral character is demonstrated by what exactly? Yeah, the slave women I have in cages over there. What the hell have I done? You know, that shows my poor moral character. I fed homeless cats for 40 years. Oh, what a evil, nasty, horrible person. Well, he is creepy as fuck, I gotta say. You know, and the whole black university thing, I'm just saying to myself, I don't think this college is actually a college. I think it's a diploma mill. You frankly just pay a high enough tuition and they'll, pass you. And that's all it is. You just maybe partially show up a little bit, and that's why he has this job, is that he's willing to be part of that fakery. I don't think he has students. You don't see any interaction by anybody on his videos. I mean, until my, haters showed up. There was no comments on his videos. But he sure is going to get egg-faced. I mean, there's just no logical way to sustain this nonsensical kinetic energy theory. It's never going to be shown that it takes 25 times the fuel to spin something 5 times as fast. It's never going to be shown that something spinning 5 times as fast does 25 times the work. None of this will ever happen. So he's going to lose. It's just a matter of getting somebody to do these better experiments. I mean, he could do them with his own little air track. He could have put 4 rubber bands on and proven that it takes 4 rubber bands to go twice as fast, and he didn't do it. Didn't bother. And again, you can tell that the experiment is flawed, just because his software obviously didn't work the same way. I mean, not to concede it looks bad, whether it was bad or not. Like, I could just say he stretched the rubber band ahead of time, right? I mean, it's not that hard to do. All I have to do is do this to this rubber band. Okay, and now I put it on the thing, and it's actually longer than it was before. It's lost its elasticity, and it's not going to get it back again until it reaches, a much cooler temperature. So all I have to do is do that ahead of time, and I've made this rubber band a lot weaker than this rubber band. The 2 rubber bands aren't the same anymore. Okay, one of them has lost a ton of elasticity. Look, you can see the giant difference in the size right there. They started the same size. Not the same size anymore. So, I mean, it's just so easy to fuck with rubber bands. It's just bullshit. Well, I don't care that you love Bathtub Guy. I don't see any attractive impulse inside of me at all. Nothing. There's no proton-electron relationship. Yeah, sure you are. Yeah, there's no chance he'll stay on this subject. He drops the soap in his own tub, just for, so he can fuck himself. I'm bending over now. Alright, he keeps asking you to prove it, which is so unfair because science should already have done. Well, duh, and I can prove it by just pointing to the Mythbuster video, right? I mean, they did it with clay, okay? No kinetic energy. They did it with physical cars, smashed them into a wall at 100 miles an hour and 50 miles an hour. Absolutely zero evidence of 2.5 the crushing. No 2.5. No 2.4. No, nowhere near 4. Nothing in the range of, oh yeah, that's like 3 times. It's pretty close. No, nothing beyond momentum alone. I mean, how many experiments do we actually have to see? I'm just saying, Brozo did the fucking lever launcher. And clearly when he did the experiment, right, the 2 mass at one distance, okay, 19 frames to move the same distance, 19 frames. Half mass, twice the distance, 11. Nowhere near 1.4. Not even close, okay? Way far away from any 1.4 shit. 11 and 19 is not 14 to 10. 14, 10 is not the same as 11 and 19. Again, I could just go back to the experiment I did do, you know, with the simple one, with just the lever suspended from above, the balance. And you have the one mass moving 4 times the velocity, the 4 mass moving 1 unit of velocity, and it perfectly balances. There's no way to explain that perfect balance. Look, fat person, I've given you warnings before, but who the fuck cares about vegan gains? Hey Gary, did you hear vegan gains? Well, why didn't he send me an email? If he wants to debate me, all he has to do is send an email. Is that too complicated? Sending an email is too complicated? I have, like, you know, more than one address, and frankly, it's pretty easy to find. I mean, I'll talk to anybody, right? So I talked to those morons today. They sent me an email. I mean, you know, they wrote a comment saying, talk. And I said, okay, fine, I'll talk to you. But like I said, I had no idea they were... I mean, frankly, there's one big problem that's happened over the last couple of years is these crazy people who are part of the club and do crazy shit. And so you really can't associate yourself in any way with people trying to force the agenda in any other way than say, I have a free speech right, I'm going to talk about what I think is ethical. You can't start a civil war when you're 4 people. You're doomed to fail. Yeah, Remy was an interesting guy. I think overall he got a lot of this stuff and just was, you know, living his life. He liked living his life, frankly. He actually drove through my town on his motorcycle, which was sort of interesting. He didn't come to visit, but he actually did come to the town I lived in, and that was really pretty interesting. But, you know, I had a few email exchanges with him over the years. I haven't heard from him in years, but, you know, he was an interesting guy. He had a very nice temperament, I have to say. He didn't get excited where, you know, I'm triggerable, and Remy was, generally speaking, more disciplined. People you talk with today wanted to embarrass you because they don't think you're an activist. Yeah, I'm not. I'm an argumentist. Okay, I'm a debater. I'm a creator of arguments. But yeah, I have no interest in subversive behavior, you know, to create some outcome. I'm not interested in being any kind of activist. I don't like imposers, and frankly, that just sounds like the definition of imposing. We're going to force you to listen. We're going to force you to pay attention. We're going to force, you know, no, not interested. Well, I'm just saying, I don't even think, you know, as a practical matter, I would advise people to be very careful who they associate with, because the government has every right. You know, I mean, if your intent is to subvert all democratic mechanisms, I think the government has a right to stop you. You know, frankly, I can't argue that they have some reason not to. Now, if you're just wishing on stars, well, I don't think they have a right to stop you. So if I wish on a star, you know, somebody dead, you know, or that my neighbor's house blows up, that's not a crime. I'm just saying they can make fun of me, and I don't see in what possible winning way. So I can't imagine how I lose in any way by distancing myself from these lunatics. Obnoxious lunatics, frankly. I don't even know what the anti-cosmic Discord server. I mean, boy, that's got to be a real fun place. I never got any of that whole Discord thing. I just never could. I couldn't possibly understand what the point of it is. All of these subreddits and sub bullshit. You're just, what the fuck attracts people to that crap? I mean, making videos is not difficult. Making a web page is even simpler. I mean, fuck. When people can't do either one of those things, you gotta say, well, you know. That's a pretty big fail. I mean, even, you know, you could write content and then send it to me or Amanda or some other person you respect and, you know, help the cause. I just don't see what's the point of this jabbering in rooms full of haters. You know, that's just... Why would I go to a blue moonshine room? Well, what would fucking provoke me to think that would be meaningful? Alright, like you said, they should show you a little respect. Well, I wasn't really asking for... I was only asking for a little respect. That is, I don't need some... You know, it just is true. Some guy speaking, you know, with a pretty harsh accent, and he's going on and on and on about a subject I fucking invented. You know, and you're just like, what the fuck, asshole? I did do it first, you know. I mean, I was there first, asshole. I don't need you to explain where the pussy is and where the boobs are and all that. I've already been there. I already had your mother. You know, it was just it was just so ridiculous. I need him to explain the subject to me. Oh, fuck you. I mean, that was just, you know, too stupid. Well, I mean, the red button is just so, it's just the funny part. They both have red buttons as their icons, right? You know. Just who said the word red button first on the internet? Who did that? No, they just went right into it. I mean, I was going to at least say, well, you know, who the hell are you people? You know. Yeah, no, they just went right to live. I showed up like 15 minutes early, 20 minutes early, and they showed up right on time. And then they just went live. And I was like, I would think there was a little tiny conversation where I said something about, you people think you're going to rescue the universe? And, you know, because I was just going to kind of mock the idea that, you know, the physics is unyielding and there's little hope that there's any other feeling life in the universe. I mean, feeling is an insanely complex brain function. I mean, what's the odds of that being duplicated? Creating a feeling? It's such a bizarre manifestation of chemistry. A feeling? Oh, shit. So, yeah, I mean, you're almost like, that's almost mockably unlikely. But yeah, it was, you know, disappointing 24 hours. You know, the moron on the physics subject and the morons on the other subject. And it's just like, oh, fuck, you just can't talk to anybody on this planet. There's just so few people that have any kind of functioning brain. Oh, just thinking of something. Yeah, I need to purchase nicotine, and I don't have a driver's license. I can't get through the stupid age checks. So if somebody feels, I'll pay, you know, I'll pay you through PayPal, and then you pay for it and send it to my address. That might be helpful, because I do have to get some more nicotine. Just irritating, all these silly fucking rules. But it's like all this. I don't get Twitter. I mean, I especially after Elon Musk basically told everybody, "I'm rich. Fuck you. I'm going to control the world." And the whole obnoxious bullshit that he pulled, and and all these liberals are still on his platform playing on it. Why would they still be there? Yeah, well, my parents quit without any trouble. My neighbor quit. He was a 50-year smoker, 40-year smoker. And it really bugged me. He survived. I just can't, I really want to just let it go, but it's just so damn, I already feel like shit. I just don't need to feel like double shit. But, we'll see. Because I just I can't. I've been feeding my brain this chemical for so long. I just can't imagine how my brain's going to function without it. But I would be courageous and grown up, but so far, no. How do you get groceries? Yeah, well, I live with somebody who does drive, so that solves that problem. But she doesn't want to, she won't show her driver's license to anybody online or to all that shit. So, I mean, I understand people's paranoia about their personal information. But yeah, the grocery thing is kind of fun. I've got, let's see, 2, 4. I've got 80 pounds of rice. 80 pounds? Yeah, 80 pounds of rice. No, I got more than that. 120 pounds of rice. Yeah. I mean, it was on sale. I probably will use it up in a year. It is my main staple. I just been. The Lyme disease really fucked me this time. I'm just getting too old to endure it. And then I got this, sorry, I don't remember the name of this stupid bacteria. Anyway, there's some other bacteria that the Lyme ticks also can carry. And so I got that infection, and that was like a month later than the Lyme disease. Maybe longer before that kicked in. And the symptoms were so weird because I had exactly what the symptoms describe. I had this intense chest pain, so I thought I was getting an ulcer or something. Because out of nowhere, I'd get this intense chest pain. And then I noticed when I was sleeping, my hip was aching me on the left side. And I can't remember what the other one. Oh, headache. And it was just, it was just such a perfect blueprint of this disease, and there's no real treatment for it, so you just have to wait for your immune system to defeat it. So it actually took quite a while, because I was having these symptoms for a month, and then they started getting a little more and more severe, and then I was done. Then it stopped. I got better. I got a little bit of a fever, and I got better. But yeah, it just lingers. It's, like something's still not right. I just don't feel right. I mean, I always feel like shit, but I just feel shittier. I mean, it's like tonight. I couldn't really eat my dinner, and I only eat one meal a day, so I should be hungry. And it's like, I was just like, yeah. Yeah, no. Anyway, it's just, I hate to be a whiner about that kind of crap, but it is making this whole project more difficult, is that I just don't feel, I feel worse. Yeah, so that, like I said, I never felt great in my life, but it, I just feel worse. But anyway, just whining. Yeah, well, it's the nymphs. They're so tiny that, because I never saw a tick. I haven't seen a tick since I lived here. Not a single tick, adult tick. I haven't seen one. And I just thought there was no chance I'm going to get Lyme disease here. Just no chance that's going to happen. It's very urban. And yeah, there are deers now that do once in a while roam the streets, but I mean, it's not a great environment. But there are a lot of birds, and I have a garden, so I attract a lot of birds, so I'm thinking maybe a fucking bird got me. And I do trim trees and bushes, but it just really bugs the fuck out of me. I really like working outdoors. I like, doing a little bit of work at a neighbor's house, make a little money, blah, 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 and it just, but, for the tiny bit of money, it ain't worth getting Lyme disease for. So anyway, it just degrades the tolerability of life. It's like the mosquitoes. The mosquitoes have gotten incessant. These little tiny, infinitesimally small mosquitoes. So I had to enclose my porch because it just wasn't any point. You couldn't be outside for more than a half hour without them just eating the shit out of you. And you don't know what kind of crap they're carrying. So, but yeah, it is just annoying that these little tiny fucking things can just ruin being outside. Yeah, it was 2-minute warning or so. Let's see. You can treat your clothing. I just, obviously I've tried off and deep woods off and all kinds of crap like that, so it's not like I'm unaware that I can cover myself in toxic chemicals. I'm just saying it's... I mean, I always take very hot baths just to, help ensure that that if I have a nymph on me somewhere, that it's going to get killed. But they're hard to fight. See, at the old place, I figured out what was happening. I mean, what happened was the cat must have brought in a little nest of nymphs or something. And so they were in the fucking house. And that's why I kept getting Lyme disease every year, is because the fucking little nymphs were in the house. They were in my couch. They were roaming about, and I did bomb the house a few times, but it just wasn't enough, because they're so tiny and they can just hide in all kinds of little crevices, and they're just, yeah, it just sucks. But I never found an adult tick attached to me. It was always these microscopically small nymphs. I mean, they're the size of a period on a piece of paper. They're literally that small. Yeah, I just didn't think of the, oh, they infected my house angle. I just, that didn't occur to me. And I just hope I don't do something to infect this house. Just, like I said, I just hate that now I have to worry about this. Yeah, I mean, look, this is just little stuff, but it's just, it's the one little thing that I enjoy doing. It's a simple pleasure, gardening and doing this stuff outside. And even that has to be tainted. It's like everything turns to shit. Ah, my battery's dead. Oh, that'll keep me from smoking. I'm out of drink also. But it's pretty late, so maybe it's time to just go. It's been a long stream. I used to take care of homeless cats. Yeah, well, cats are just impossible to ignore. When they're sitting there looking at you with that face. It's just, yeah. Yeah, I just the more you hang around cats, the more you appreciate just how interesting whatever is going on in their little brains is. They have so many little quirks and things about them. They're all just so different, and they're all, have their little ways of interacting, and they're just all so fucking charming, frankly. They have such a graceful indelicacy, But anyway, enough of that. So, till the next time and such and so forth and whatnot. Thanks for the participation that was provided. It wasn't terrible. I appreciate that. And we'll see what happens. I'm confident about how all this ends, and that's the part that just makes it so irritating. I know I'm absolutely right, there's just no doubt about it. And all of this bullshit is just such pointless waste. So, till the next time, and such and so forth and whatnot. Well, I can't go until I have the right frickin' window open. Alright, so, end stream. And such.